Good morning, my dear student. On the behalf of KTGM College Nasik and Department of Chemistry of this college, I am Dr. S.R. Labhade welcomes you to the lecture on thermal methods of analysis. Student, in previous lecture we discussed what are the different thermal methods of analysis and what are the different methods of thermogravimetric analysis. In thermogravimetry, heating and weighing of sample is carried out in a thermobalance. Therefore, we also discuss the instrumentation of thermobalance. In today's lecture, we discuss the result obtained in thermogravimetric analysis, that is a thermogram. Therefore, thermogravimetric curve or a thermogram. We know that thermogravimetry, that is a technique of qualitative and quantitative analysis in which the change in weight of a substance is measured as a function of time or sometimes as a function of temperature. And result obtained in thermogravimetric analysis is in the form of thermogravimetric curve, that is also called as thermogram. It is also called as pyrolysis curve. Therefore, the result obtained in thermogravimetric analysis is in the form of thermogravimetric curve or a thermogram. Thermogram is a plot of or a graph of loss in weight of a substance versus temperature or time when temperature is constant. This graph is called as a thermogram or thermogravimetric curve. This thermogravimetric curve is like this. Here, loss in weight in gram or milligram, and here temperature in degrees centigrade, or sometimes it may be time when T is constant. This curve is consisting of a shape in this fashion, and in this case, here this is A, this is A dash, this is B dash, this is B. Therefore, here a step-shape curve is obtained in a thermogravimetric analysis, that is called as thermogram. This figure is a ideal thermogravimetric curve or a thermogram, or it is also called as a pyrolysis curve. Therefore, total results obtained in thermogravimetric analysis is in this form. This is called as thermogram, which is a graph of loss in weight of substance as a function of temperature. Therefore, this thermogram is utilized for different purposes in chemical analysis. Therefore, the applications of thermogram. First application is determination of thermal stability of a substance. In a thermogram, this horizontal region indicates there is no change in weight. That indicates this is a temperature range in which that substance is stable. Therefore, this is a temperature range in which that substance does not change its physical and chemical properties. And therefore, here the horizontal region, that is a temperature range which indicates the thermal stability of the substance. Therefore, the horizontal region in thermogram indicates the temperature range, in which substance, in which there is no loss in weight. Therefore, the horizontal region in which there is no loss in weight, that indicates the temperature range in which the compound is stable. That means that is a temperature range in which there is stability of the substance. Therefore, thermal stability is the temperature range in which substance does not change its physical or chemical properties, and that is called as thermal stability. Therefore, horizontal region on a thermogram that directly indicates the thermal stability of the substance. The thermal stability of this substance is also useful for selection of drying temperature of the substance. Therefore, here horizontal region that indicates the thermal stability, and in this case we can say that compound is stable, and therefore within that temperature range we can heat that substance or we can dry that substance, because within that temperature range there is no change in physical or chemical property of substance, and therefore here we can also select a drying temperature by this horizontal region, or that is a temperature range in which substance is stable by. Now next application of this thermogram, here the curved portion directly indicates the curved portion on thermogram indicates the loss in weight. The loss in weight is utilized for quantitative analysis. Therefore, the loss in weight can be utilized for quantitative analysis of the substance, Therefore, next application, that is a quantitative analysis. Therefore, thermogram is most important use of the thermogram is the quantitative analysis of substance. That means, if the decomposition reaction is known, decomposition reaction is known, then the loss in weight is due to loss of some volatile product from the substance when it is heated. And if the decomposition reaction is known, then we can determine the amount of that material. For example, CaCO3, when it is heated to very high temperature, it gives CaO plus CO2. Therefore, loss in carbon dioxide and amount of calcium carbonate, that we can correlate for determination of substance. Here 44 is the molecular weight of CO2 and 100 is the molecular weight of calcium carbonate. If there is loss of 44 gram of CO2, that indicates 100 gram of calcium carbonate in the sample. Depending upon the amount of particular substance loss, we can determine its parent compound. And this is the most important use in quantitative analysis. In addition to this, we also determine the purity of this substance. Therefore, thermogram is also useful for determination of purity of substance. That means, using this relationship, we can find out the amount of substance. Suppose this calcium carbonate is naturally occurring. Therefore, if we place this naturally occurring calcium carbonate in a thermobalance, and if we carry out its heating reaction, decomposition reaction, and if we measure the amount of amount of carbon dioxide loss, then amount of carbon dioxide loss in the reaction that can be utilized for determination of purity of this calcium carbonate. And therefore, here the quantitative analysis as well as determination of purity of substance is also possible from the thermogram. In addition to this, thermogram is also useful for determination of percent composition of the substance. If we have two or more components, in a mixture, and if we place that mixture in a thermobalance, and if we study the decomposition reaction, and if we record the rate, if we record the mass of loss in weight of the substance, then we can also determine the amount of each component present in the mixture, that is a determination of percent composition of the substance. Therefore, percent composition of the mixture that also determined by using this thermogram. Therefore, here this is the result obtained in thermogravimetric analysis, that is a graph of loss in weight of substance versus temperature. This curve is utilized for a determination of thermal stability of substance. We can select a drying temperature for a particular substance, then quantitative analysis of substance, determination of purity of the substance, as well as we can determine the percent composition of a mixture by using this thermogram or thermogravimetric curve. Student, with the thermogravimetric curve or pyrolysis curve, we can discuss the application of thermogram in determination of purity of substance, in quantitative analysis, and in determination of composition of the material. Here, draw and explain the thermogravimetric curve of calcium oxalate dihydrated when heated from 1 degree to 1500 degrees centigrade. In this case, we have to draw the thermogravimetric curve of this or pyrolysis curve of calcium oxalate dihydrated, and we have to explain that curve with respect to the decomposition reaction. We know that pyrolysis curve, that is a graph of here a loss in weight or weight in gram or milligram versus temperature in degree centigrade. Here calcium oxalate generally obtained in dihydrated form, and this calcium oxalate is stable up to temperature 134 degrees centigrade. After that, here if temperature more than this, it undergo decomposition to anhydrous CaC2O4. This will be takes place T26, and calcium oxalate is stable up to temperature 398 degrees centigrade. After that, again there is loss, and here at 478 degree total calcium oxalate is get decomposed to calcium carbonate. Again calcium carbonate is get decomposed at a temperature 635 degrees centigrade into calcium oxide, where temperature is 838, and after that 1025 degrees centigrade calcium oxalate get converted to calcium carbonate. Student, this is a pyrolysis curve or a thermogravimetric curve of calcium oxalate dihydrated. Calcium oxalate dihydrated is stable up to temperature 134 degrees centigrade. When temperature is greater than this, that means CaC2O4 twice H2O is get decomposed to anhydrous calcium oxalate, plus there is loss of 2 water molecules. This loss at temperature region 134 to 226, that is because of loss in weight due to the loss in water molecules of calcium oxalate. Therefore, 2 water molecules from this calcium oxalate are get lost, and here calcium oxalate anhydrous is obtained. This calcium oxalate anhydrous is stable up to temperature 398 degrees centigrade. After that, this temperature, this calcium oxalate CaC2O4 get converted to CaCO3 plus CO. There is loss of carbon dioxide, and here carbon dioxide is lost when temperature is about 400 degrees centigrade. Temperature greater than 300 degrees centigrade up to 478, total calcium oxalate anhydrous is converted into calcium carbonate. This calcium carbonate has further heated. Those are get converted into calcium oxalate. And here calcium oxalate is stable, calcium carbonate is stable at temperature up to 635. Temperature greater than this calcium carbonate get converted to calcium oxide plus CO2. Therefore, here the decomposition reaction or a decomposition step in calcium oxalate are found to be three. Calcium oxalate dihydrated decomposes to calcium oxalate anhydrous, anhydrous calcium oxalate converted to calcium carbonate, and finally calcium carbonate is converted to calcium oxide. Therefore, these are the three decomposition reactions, and those are taking place at different temperature. Here horizontal region equation that indicates the thermal stability of substance. Calcium oxalate dihydrated is stable up to 134 degrees centigrade. Anhydrous calcium oxalate is stable up to 398 degrees centigrade. Calcium carbonate is stable up to 635 degrees centigrade. And calcium oxide is stable at any temperature that is more than 1000 degrees centigrade. That means here thermal stability we can obtain from this pyrolysis curve. This is a figure that is a pyrolysis curve or thermogravimetric curve of calcium oxalate dihydrated when heated from 1 degree to 1025 degrees centigrade. Therefore, here this curve gives us information about the stability of different components formed in the decomposition reaction, as well as it indicates whatever the material loss in the reaction. Therefore, based on the loss of material in the reaction, we can also utilize this same pyrolysis curve for determination of purity or determination of amount of calcium oxalate. Here, the problem, we can solve one problem based on this. A calcium oxalate CaC2O4 twice H2O is prepared and purified and dried in laboratory. If a 0.154 gram of dry product is heated in thermobalance up to 250 degrees centigrade. The loss in weight was found equal to the loss in weight was found 0.032 gram at this temperature. Now problem is that determine purity of calcium oxalate dihydrated. Now in this case, calcium oxalate is prepared in the laboratory, it is recrystallized and it is dried. After that, for determination of purity of substance, sample is placed in a thermobalance and up to temperature 250 degrees centigrade, the loss in weight is recorded. Therefore, when we heat this calcium oxalate dihydrated up to 250 degrees centigrade, we must know that there is loss of a water molecule. Therefore, water molecules are lost. Therefore, decomposition reaction is CaC2O4 twice H2O heated to 250 degrees centigrade. It gives CaC2O4 anhydrous plus twice H2O. Here twice H2O, that is a amount of material loss in a decomposition reaction. In this case, the molecular weight of this is 164 gram per mole, and here twice H2O means 36. 80 into 2 means 36 gram. From this decomposition reaction we can say that if 164 gram of pure calcium oxalate dihydrated is present, then there is loss of 36 gram of CO2. Sorry, 36 gram of water molecule. Therefore here, by this relationship we can write here 36 gram of loss corresponding to 164 gram of CaC2O4. Therefore, 0.032 gram loss corresponding to how much? And therefore here 164 into 0.032 divided by 36, and by calculation this value is 146 gram. Therefore here 36 gram loss corresponding to 164 gram of calcium oxalate dihydrated. Therefore this much gram corresponding to 0.146 gram of calcium oxalate we can find by calculation. Now we can say that if 0.145 gram of sample contained, if 0.154 gram of CaC2O4 twice H2O, then it is 100% pure. But here we have this amount we have 0.146 gram of CaC2O4 twice H2O, therefore corresponding to how much purity? If 0.154 gram of sample contain same amount of that calcium oxalate monohydrated, then it dihydrated, then it is 100% pure. But here by calculation we found this value is less than this, therefore this corresponding to how much percent pure. Therefore percent purity is equal to this 0.146 divided by 0.154 into 100, and it is equal to 94.8%. In this way we can determine the purity of substance from the loss in weight or from the thermogram. Student oxalate, draw and explain the thermogram of or thermogravimetric curve of magnesium oxalate dihydrated when heated from 1 degree centigrade to 900 degree centigrade. Here calcium oxalate have 3 stages of decomposition. Now magnesium oxalate have only 2 stages of decomposition, twice H2O. This magnesium oxalate is stable up to temperature 176 degree centigrade. Temperature greater than this, there is loss in water molecules. Therefore, when temperature reaches 233, there is total loss in water molecules. We have a magnesium oxalate anhydrous. When temperature reaches to 397 degree and up to 487 degree, there is complete loss in weight, and after that here when we heat this compound up to 900 degree centigrade, then we have only magnesium oxide. That means here this is the first stage of decomposition and this is the second stage of decomposition. That means here in first stage of decomposition, definitely you can say that there is loss in water molecule. MgC2O4 twice H2O is get converted to anhydrous MgC2O4 plus twice H2O are lost. Therefore, magnesium oxalate thus formed, it is stable up to 397 degrees centigrade. When temperature greater than this, here this magnesium oxalate loses a carbon monoxide as well as carbon dioxide. Therefore, both carbon dioxide as well as carbon monoxide both are lost in second stage of decomposition. Therefore, in comparison to calcium oxalate dehydrated, magnesium oxalate dehydrated have only two stages of decomposition. Calcium oxalate dehydrated have 3 stages of decomposition, where loss of carbon dioxide and carbon monoxide takes place in a different stages of decomposition. Student, this is about the thermogram or pyrolysis curve of magnesium oxalate dehydrated, that consisting of 2 stages of decomposition.